At the tender age of 6, when kids are usually attracted to toys and crayons, our DevOps stalwart was so enamored by the science of automation and computers that it kicked off his computer programming career at the tender age. Surprising, isn't it? His approach to focus on a computer's ability to crunch huge chunks of data consistently and rapidly made him sail through some of the most challenging projects in his professional career. The Israeli Defense Forces 8200 being one such example, for which he bagged the esteemed Israeli Security Prize given by the president. During his tenure at Checkpoint, he founded Indeni with the aim of solving human error and dependency in software technology through automation. Through his in depth study on continuous security for infrastructure as code, he'll be sharing the transition to cloud native development, making scanning infrastructure as code for known issues a critical security activity of the CI CD process. With that, let's now welcome onto our screens with a hearty round of applause Mr. Yoni Leitersdorf.
Hey everybody, my name is Yoni. It's good to be here today. Today we're going to talk about a case study, our own experience at Indeni of trying to do continuous security for infrastructure as code. So I'm going to share with you a bit about the challenges that we faced from a cloud security perspective and how we solve that through doing infrastructure as code security. If you want, you can follow up with me after this presentation. My Twitter handle is up here, Yonadavel, and then also my email, y@indeni.com. So feel free to reach out to me after the presentation if you want to ask or talk about anything. Very open to that. So as you heard, quick background about myself. I've been in coding for a while, big into security. And so this whole concept of doing security for infrastructure as code is something that I can tell you I'm very, very passionate about on a personal basis. So we're going to talk a bit about the challenges that we had at Indeni, what were our problems in the general situation. Then we're going to talk about the solution that we ended up building and using. We're going to see a very short demo and then a few lessons learned and a recap. So hopefully you find this very interesting. Listen to. So everybody knows, I think at this point, that cloud misconfiguration is the number one risk to cloud environments in 2021. So essentially, just getting your infrastructure wrong, making a mistake, using a default value, configuring something incorrectly is essentially the number one issue that can cause security problems and hacks in the cloud environment. And of course, the average breach costs a lot of money. So, you already know the fact that getting cloud configuration right is very, very important. Let's talk a bit about the problems that are causing us to get into this situation. So if you think about it, a lot of organizations today are adopting what's called cloud native development. But basically what it means is that applications are built to run in the cloud. So instead of, something that was done in the past where you would build an application and you would run it on physical machines or VMs, and then you would lift and shift it into the cloud and run it on VMs in the cloud. What a lot of people are doing today, ourselves included at Indeni, we're actually building the entire environment to run in the cloud. And so we're leveraging not only the infrastructure as a service capabilities, but also the platform as a service capabilities that are offered by the cloud providers. In addition, we're leveraging a lot of SaaS in order to actually improve our processes. So for example, a lot of our monitoring and our CI/CD, et cetera, use those kinds of technologies. Now, once you've decided that everything is going to be cloud native in your architecture, you have the possibility of using something that's called infrastructure as code. So essentially, you can describe the infrastructure that you need in a code language like Terraform or CloudFormation, Pulumi, Bicep, et cetera. We at Indeni decided to use Terraform. It was the most convenient for us. Also, Terraform is to some extent cross-cloud. That's a bit debatable about how cross-cloud it actually is, but to some extent, from a process perspective, it is cross-cloud. And so we decided to use Terraform. And what we did was we built our entire cloud environment for a product that we have and had in Terraform. And then what we did is we wrapped that up in CI/CD. So essentially, we use Jenkins. We're going to talk about it in a moment how we did that, but we use Jenkins to automate the verification of the Terraform code and then the actual deployment of the Terraform code. Now, something that was really important for us is to actually build the environment in a secure fashion. So the product that we built this for is a product called the Indeni Security Infrastructure Automation Platform. And that product interacts with firewalls and web security gateways and other security devices that are deployed in enterprises all over the world. And so it has access to some very sensitive material, and it was important for us that the cloud environment would be secure and always secure as kind of an inherent part of how it's built. But then on the other hand, we wanted to keep our feature velocity. We wanted to be able to release features as fast as we can and not slow down our process of releasing new features because our desire to be secure. And that's an interesting trade-off that we'll talk about. And then lastly, it was important for us to be SOC 2 compliant. The organizations we work with have a lot of value in SOC 2, especially SOC 2 Type 2. And we wanted to achieve that compliance through the kind of secure design that we had. So these were the main requirements for us as an organization. So if we dig a bit deeper into how this kind of looked like at a CI/CD level, of course, we're here at a DevOps conference. We can see that obviously we have continuous integration. And basically what that means to us is that the code that is submitted by a developer goes through a lot of automated tests as well as human code review before it gets integrated. Now, we chose to use Jenkins, by the way, but you can use a lot of different systems out there. We just were comfortable with Jenkins when we were building this. So first of all, you go through continuous integration and you integrate the code. So the code can be application code, which is written in Python, and some of it was written in Scala and other languages. And then there's the infrastructure code, which, as I said, is Terraform in our case. So all of that would get integrated into the main branch. From there, what would happen is that Jenkins would take the code every single time, by the way, that you merge the code, you merge a pull request. It would take the code and run through a full process. And when it runs through the full process, one of the things it does is it actually runs the Terraform code, does the plan and apply for Terraform, and deploys the environment into a deploys the code into a dev environment. So we always had a dev environment that was up to date with our code base. And that way you can get very quick feedback on whatever you just merge, whether things are working, maybe there's some kind of issue that needs to be resolved and you need to roll back or fix whatever you did. So that gave us a lot of consistency and confidence regarding what we were building. And of course, there's a regression test to make sure that the dev environment works. And then once we are ready and we're ready to go and everything's good and we're ready to make a new production release of this cloud environment, it's just a click of a button and then Jenkins goes and deploys into staging and then into production, as you can see here. And again, it runs Terraform, makes the changes in the environment, and then deploys application code and does the regression tests. Now, we decided, in our case, we use AWS, and we decided to have separate AWS accounts for each of the environments. We have a separate one for dev, and then another one for staging, and another one for prod. So this structure was actually very good for us from a speed and agility perspective. So it allowed us to add new features, new capabilities really quickly by doing this. And I highly recommend this as an approach. It also gave us an opportunity to do something else that is very interesting, and that's injecting security into this. And that's what we're going to talk about today. So when you have your environment deployed and you're looking to secure that environment, you're looking to lock down and make sure that you're secure and you're compliant, you go through essentially a series of steps, or essentially these are the steps that we took. The first thing was to discover what we actually care about. So it is impossible to secure everything. Just impossible. That nobody can do it. Nobody has the time to do it. It's just too much work, and you can't. But you can think about this thing as kind of a Pareto principle. You can focus on what is most important to you and focus. And if you focus your efforts there, you'll find that you get the most value, but you don't need to invest as much time as securing everything. So it was really important for us to start with a discovery phase where we said, what data do we care about and where is that data in the cloud environment? And when you do that, you realize that First of all, the most important data that we want to secure is the customer data, not even our own data, rather the customer data. And so we mapped where is the customer data flowing through, like, what services is it flowing through, the transport layer, and then also where it's stored, and then where does it move from the storage. Okay. So you start by doing that. You start by kind of trying to find out where everything is and how it's flowing. And it's not that easy to do, by the way. It's we thought it would be easier, but it wasn't. And we had to dig in deep in order to understand that. And then once you know where the customer data is, then you can essentially say, okay, this is the area that I want to secure and I want to lock down in order to protect the customer data. So what we did is we moved forward and started looking at cloud security posture management tools. And cloud security posture management tools like Checkpoint 09, Prisma Cloud, there are dozens and dozens of different tools today, even ones offered by the cloud security providers themselves. They find a lot of issues. So if you look at an environment that is already deployed in the cloud, you'll see that these CSPM tools, they find hundreds and hundreds, if not thousands, of issues. And as a security practitioner, what we needed to do is to actually look at these issues and kind of shorten it down. So basically say, just like we did with the customer data, where we said, okay, this is the area we're interested in, we now had to look at the alerts from the CSPM and figure out which ones are actually interesting and then focus on just those. Okay. And that reduced the number of issues by over 90%. Once we had that short list of issues, we then needed to work with the developers. So the security side of Indeni, and this is true for almost every organization, the security side of Indeni is not allowed to change the cloud environment. So if a security practitioner sees the alerts coming out of a CSPM, they can't actually make any changes to the cloud. They can only say, okay, this is an alert. Somebody needs to action this. So what they do is they open a Jira ticket. So we use Jira, and of course there are other solutions as well, but basically you open a ticket and you say in the ticket, this is a security issue. This is what it is. This is a screenshot from my CSPM tool. We need to fix this. And you open the ticket and you hand it over to the developers to complete the ticket. And after we opened a whole bunch of tickets, we realized it takes a very long time for these tickets to be resolved. And we realized that actually most of them are not even actually being resolved at all. And we tried to understand why. And when we dug into it, we realized that these issues are very hard to fix. So once something is in production, fixing it is very, very time consuming because the developer now needs to do a context switch and kind of remember what they built there. But also a lot of things in production, if you try to make a configuration change, you have an outage, you need a maintenance window. In some cases, you need to take it back up and restore, like the case of a database that is encrypted. So it's a huge pain to actually fix issues that were found by a CSPM tool. And then in addition to all of that, the security bugs themselves, they always get deprioritized because we need to push features out to customers and increase the business value. So this was actually a very frustrating part of the process. Not only did we get a lot of issues from CSPM, but also those issues were not getting remediated. So you feel like you're wasting your time. And then you try to continue this, right, to this kind of process again and again and do it on an ongoing basis and kind of establish a practice around it. But what we found is that there's just not enough people in the world, security practitioners, that are capable of doing this entire process we talked about. And then also the issues don't get resolved. So the entire thing is not scalable. And we were chasing our tails because even when we were looking at a cloud environment, the cloud environment kept changing. Because if you remember from the previous slide, it's very easy to change the cloud environment. It's very streamlined. So you're kind of chasing your tail there. Very frustrating process, I can tell you, from our end. And that's something that we were looking to resolve. And I want to talk with you guys a bit today about how we resolved that, how we addressed it. So as we said, finding issues late in the process doesn't make sense. And so we thought, you know what? Maybe we move the security evaluation to the beginning of the process. We use Terraform, right? We build our infrastructure using Terraform so we can actually evaluate security issues in Terraform. Why wait for the environment to be built? That's a pretty big step. So we have the opportunity to actually perform security testing before deployment. So if you think about the CI/CD I was showing you earlier, we can actually move security testing early in the process there. So essentially, you can include the analysis of infrastructure right, of infrastructure code in these phases. So you can do it here in CD, you can do it in the continuous deployment as well. And then there's actually ways to do it in continuous integration if you'd like. And if you do this and you find security issues within the flow here, then all of a sudden you can address security issues early. And they're a lot cheaper to fix at that point. And so you end up with developers that are happier and also security personnel that are happier because the cloud environment is far more secure. So we started looking at static analysis tools. And what we found was that they're really noisy. So this is about 2 years ago. And we found that the available static analysis or infrastructure as code static analysis tools were just throwing a whole bunch of false positives at us. And that causes a problem because if a tool stops your process, let's say in your Jenkins flow for noise, developers get really, really frustrated. And then they just throw the tool out or they'll ask you to turn it off. So if you have something that has a lot of false positives, it's pretty bad. And the result is that, of course, security issues don't get handled again. The additional aspect here is that the static analysis tools were missing a big part of the picture for us. So, for example, they couldn't tell us about configuration drift because if you only look at the Terraform code and not at your live environment, you can't tell if the code is drifting or if the environment is drifting. The IAM-based alerts were really limited because the code doesn't necessarily tell you how the workload is going to use the IAM permission. And so the feedback that you're getting is pretty low. And then we also found out that a lot of what we were concerned about from a security perspective and protecting our customer data, the static analysis tools were incapable of helping us with because they didn't fully understand how all of the resources in our environment relate to one another. So static analysis had a lot of promise for us, to solving the issues we talked about earlier, but of course, there are all these gaps. So at that point, we thought, what, how about we try to solve the problem ourselves? And we ended up building a product called CloudRail, but originally was kind of more of a tool for ourselves. And the idea here is to augment static analysis with dynamic analysis. So instead of just looking at the code, let's look at how the code actually behaves in the live environment and how the live environment actually looks like. So the idea is that you look at your tool looks at the code itself, a snapshot of the live environment, and merges the two together. And that allows you to look at something like, let's say you have an RDS database in your code that is built in a specific subnet, but the subnet is already defined in the live environment. A dynamic analysis tool is capable of connecting these dots and understanding how everything works together. And therefore, you're going to get far more specific violations. So for example, it will actually be able to tell you, hey, your database is in a public subnet, or your database is not in a public subnet. And so you shouldn't care as far as, the public accessibility is concerned. Another, by the way, interesting part of this is that a given environment is usually built by multiple stacks of infrastructure code. And so in a normal situation, you only look at one of them at every given moment. But if you do dynamic analysis, you can actually connect the dots between the repositories and understand how a subnet that was defined in one stack is being used in another stack. And that actually gives you the full picture. So let's take a quick look about how cloud misconfigurations are identified in static analysis versus dynamic analysis. So in the static analysis situation, for example, if you remember, we're talking about drift. In a static analysis situation, you only look at the Terraform code and you see that there's some kind of set policy that was assigned to a user or a group, and you can analyze that policy. Okay. But if you also look at the live environment, you can catch an interesting situation that happens often where somebody is granted permissions outside of the infrastructure as code process. So imagine I'm a user and I was granted limited policy. And now I'm, the code was deployed to the live environment and I find out that my policy is not enough. So I open a ticket and let's say an engineer circumvents the infrastructure as code process and grants me another policy in the live environment without changing the code. They can do that because they have permissions to do it. A lot of times cloud engineers have the ability to do that. Now, when you do that through the console, in our case, the AWS console, your code is not aware of this. And so if you only do static analysis, you're not aware that something like this happened and you miss it. And you actually have an exposure here that you don't know that is happening. So with dynamic analysis, you can actually be aware of this and you can alert the user and say, listen, you define in your code that this user, me, let's say, has only a limited policy, but in reality, this user was granted admin by somebody who circumvented your process. That's really important to know. Another example is around privilege escalation. So, just to kind of differentiate to the previous one is a situation where I was granted more permissions by circumventing the process. But here, what you have is a situation where you have multiple sets of code building different parts of your infrastructure. So, for example, you have one set of code that is building a policy, another code that is building the either the IAM role or the IAM user, let's say IAM role, that uses that policy, and then another set of code that is building your Lambda function that is using that role. Okay, and when you only look at each and every one of these on their own, just to the code level, it's hard to understand whether there's a potential for privilege escalation. But if you connect all the dots, then you can all of a sudden see that your Lambda has the ability to change its own role. Okay, so decide which roles it wants to use. And then it also, through another form of access, can have the ability to create a new function and invoke it. Okay, so this on its own, maybe not necessarily that big of a problem. Not great because you have resource as an asterisk, a wildcard, but not necessarily a huge problem. And also this on its own might not be a huge problem. They're not great, but they're not a huge problem, each of them on their own. But if you give one entity both of these policies together, then that entity is essentially, it can do whatever it wants because it can create a Lambda, it can load code into it, it can give whatever role it wants that Lambda, and then it can invoke that Lambda. And so, you can elevate yourself to admin. And again, if each of these sections is built in a different stack of code, it's impossible to connect the dots. Whereas if you're doing dynamic analysis, you can actually understand how all of this works together. One more example is around protecting S3 buckets. So when you think about S3 buckets in AWS, the first thing is don't make your bucket public, of course. So you do private, right? But even when the bucket is private, when you're pulling data from the bucket, you're actually doing it over a public endpoint that AWS exposes. So if you have an EC2 instance or Lambda, or even on your own workstation, when you're pulling data from an S3 bucket, even though it's private from a permission perspective, you're still going over the internet, okay, to do it. Now, imagine you've got some compute capabilities running in a private subnet. For them to get to the data that they need to access in the bucket, normally they would need to go from the private subnet through a NAT or internet gateway over to your bucket, right? So the subnet would have to go out there to the internet and reach the bucket. And that actually defeats part of the point of having a private subnet, because when you have a private subnet, it's not just about nobody being able to come into the subnet, but also compute resources not being able to go out, because that would allow data exfiltration. And so AWS solves this by introducing the VPC endpoint concept, where in your subnet, you can actually go to the bucket through a kind of an internal network that AWS has. And so your subnet is never connected to the internet. You don't have data exfiltration risks in that kind of situation. So that's the security concept. Now, if you think about it from an infrastructure as code analysis, static versus dynamic, in a static situation, it's very hard to determine this because the VPC could be defined elsewhere. The VPC endpoint could be defined elsewhere. The internet gateway may be a default one, et cetera, et cetera. So static code analysis is completely incapable of connecting all these dots. But dynamic is capable, because dynamic can look at your compute resources that you're building, can understand the subnet, can understand what VPC it's in, NAT gateway and internet gateway, and of course all the other functions here, and can connect all of that together. And the result is that you have a much more specific and relevant analysis of your environment. So those were a few examples of what you could do with dynamic analysis versus static analysis. So I want to show you a couple of things here. One moment. So let's start with this link here that you're seeing in this slide. So this link is a public repository on GitHub that compares some of the IAC security tools. And it starts by comparing them from a static analysis perspective. So you have a few of the tools here, and they're ones added all the time. But basically, it has a list of all kinds of security misconfigurations that are caught by these tools. Right now, it's focused on Terraform and AWS, but as time progresses, more and more languages and cloud environments will be added. But it's really interesting to see that there are a bunch of different tools out there, some of them open source, some of them freemium, some of them not. And then they have different levels of catch rates for these issues. Now, all of this, again, is static analysis, so it's kind of very, very specific cases, but it's interesting to see how these operate. Now, if you use an ISC security tool, and I'm going to use Cloudtrail as an example, but there are others as well. If you use an ISC security tool, you can now get feedback directly into your process. So, for example, this is a GitHub repo, and there's the CI for this repo, and in it you're going to see an action for Cloudtrail. Okay, and Cloudtrail provides the SARA format that GitHub uses for finding security issues. And so when you open a pull request, it will automatically execute Cloudtrail in this case and give you direct feedback on your code. So for example, here I'm building a database and Cloudtrail is telling me that it's missing a tag, it's using the default VPC, it's using the default security group, and then also it's not encrypted at rest. And if you click on this, you can actually see more details about how you should actually fix this. It's just a matter of adding an argument. Now, adding this argument can take you less than a minute and you're good to go. You're great, right? Obviously, if the database is already deployed, making it encrypted can actually take you easily 3-4 days to complete. So finding this in infrastructure as code is very valuable. But the other interesting part I wanted to show here is around the dynamic analysis part of this. So Cloudtrail actually is aware of your default VPC, knows that it exists, knows that you're using it, and knows how it's configured, because you could delete the VPC, the default VPC, or you can change its configuration. And so when it does the analysis of this DB and it sees this security group with this specific ID, Cloudtrail can actually say, hold on, this ID, I'm familiar with it. I saw it in the live environment. It's the default security group of the default VPC, and therefore this is not okay. Okay, so dynamic analysis can do this. Static analysis would not. So static analysis would not have these two issues listed at all, but dynamic analysis does. And so you can see, you can actually integrate your analysis easily into your CI/CD flow. In this case, we used GitHub Actions, and it's just seamless, and you can get the feedback immediately, solve security issues much faster than you would otherwise. So going back to the presentation here. So let's kind of summarize what we've learned here. So first of all, we need to actually think about things from a people perspective before we think about the technology. I mean, we talked a lot here about static analysis and dynamic analysis, but kind of the concept that we could hear through the story is that at the end of the day, you have people, you have developers who really want to deliver as fast as they can and complete the features and functionality that they have as fast as they can. But you also have security people who are frustrated with working with CSPM tools and frustrated that whatever they do find, nobody resolves. So it's the people part. So that's the first thing you need to realize. The next thing is understand that you need partners on both sides. So developers need to work together with security. Security needs to work together with developers. The security team can't just add a tool into CI/CD. The DevOps people are the ones who need to do it. And the developers need to accept it as a tool. So you need to think about how people relate to one another. And then eventually you need to establish a joint goal. In our case, what we did was the joint goal of the company is to be successful, right? And if you think about successful, there's the business success. And a big part of the business success is treating our customers correctly and treating our customers' data correctly. And so if you establish that as a goal and developers and security personnel all think about it, then they can actually work together. So the people aspect is really, really important. There's a certain set of steps that we recommend following when you're trying to implement ISC security. The first thing is you start with visibility. Okay, so before you enforce anything or block any CI or CD flows, just start with visibility. Put the ISC security tool in your process and set it into kind of detect mode only. Cloudtrail, by the way, does that by default. And just get an understanding of what you have and what kind of problems you have and what kind of resources are misconfigured, et cetera. And then you slowly start adding controls without getting in the developer's way. Because remember earlier, you don't want the developers to kick you out if you're stopping the CI/CD flow for no good reason. And then you start kind of inching up the enforcement. You go with the rules that have no violations, and then you add the rules that do have violations, but after the violations have been resolved, and you kind of inch up the heat. So there are a lot of people say often, how do you cook a frog? You put it in cold water and then you heat it up. So it's kind of a similar concept here. You don't start, full boil when you deploy something like this. You actually you start small and slowly move up from there. And then don't start with your production environment. That's actually a really interesting lesson that we learned. We originally thought, okay, we'll enforce this on our production environment and not our dev because customer data is in the production environment. But that's actually contrary to the way CI/CD works, because the concept of CI/CD is that you run into all the problems in dev, and then theoretically you should have no problems going from dev to production. You shouldn't run into anything new. So if you enforce your security requirements only in production, then you actually have a problem because you're only going to run into the security issues when you're trying to push from dev to production. Very frustrating for the DevOps people. And so you should actually start with your dev environment, not your production environment. So it's a bit backwards from what you would normally think, especially when you think about it from a security perspective. But from a DevOps flow perspective, you should start with your dev side, not your production. Then eventually, obviously, we've measured our results here, and we have a set of metrics. So there's how many new validations are being added, and our goal was obviously to achieve 0, so no new resources that are validating anything. And then the next metric is how many issues exist in our environment, and we want that to trend downwards, of course, so that there are less and less issues over time. We wanted to measure how long it takes from the moment that we find a problem until it gets resolved. If you remember in the beginning, we talked about security issues never being resolved. So we wanted to really measure that. And then, of course, being compliant at all times with SOC 2. So these are the metrics we've established, and we think they're pretty useful for using this. So to wrap up, we think that the journey should look like this. You start with going into infrastructure as code. So instead of deploying infrastructure manually, use infrastructure as code to do it. You wrap it in CI/CD so that it's very, very consistent. You then add static analysis from a security perspective. You advance the dynamic analysis in order to get far more accurate results, as well as a lot of aspects that are missed in static analysis. And that allows you to actually reach policy enforcement and continuous compliance, which is kind of the goal if you think about it. So this is the roadmap that we've seen that works well. Oops, sorry about that. So that's it. Make sure you're automating your deployment with CI/CD, catch security issues early in the development cycle before deployment so that you don't need to fix them later. It's not just a matter of technology, static versus dynamic analysis, but a lot of it is actually people and where you're integrating it into the process. And really, you can achieve continuous compliance. That holy grail is actually within reach today. That's it. That was me. Hopefully, you found this interesting. Again, you can reach out to me on Twitter, YONADABL, or email y@indeni.com, also on LinkedIn. Thank you very much, and hopefully you found this interesting. Enjoy the rest of the conference.